What if the most disturbing idea in modern physics has nothing to do with black holes, or dark matter, or the universe ending in cold silence billions of years from now? What if it is about you, right now, sitting exactly where you are? There is a thread running through quantum mechanics, built from real equations defended by serious physicists, that suggests from your own first-person perspective you may never experience the moment of your own death. Not as a comfort, not as a promise, as a logical consequence of the same physics that runs every device you own. It starts in 1957, when a graduate student named Hugh Everett refused to let the wave function collapse. It runs through 1998, when Max Tegmark followed that refusal all the way to its most disturbing conclusion. And it ends somewhere that should feel like relief, but doesn't. Tonight we walk the whole road. The measurement problem, the many worlds interpretation, the branching of identity itself, and the 4 reasons the argument almost certainly falls apart, in a way that is somehow more unsettling than if it had held together. I'll say this up front. Half the comments on this video will laugh it off. The other half won't sleep tonight. I genuinely do not know which half is right. Get comfortable. Subscribe if this is your kind of rabbit hole. And stay until the end, because the real question we are building toward is not whether quantum mechanics keeps you alive forever. It's what exactly is left once you find out what it's actually keeping. Part 1. The claim you can't escape. You may never experience your own death, not in the poetic sense, not as a metaphor for legacy or memory or the people who carry your name forward, not as a spiritual promise wrapped in the language of whatever tradition raised you. I mean it in the most literal, structural, physically grounded sense available to modern science. There is an argument, built from real mathematics, tested physics, and the same equations that gave us transistors, lasers, and the screens you're reading this on, that suggests, with uncomfortable logical consistency, that from your own first-person perspective, the moment of your death may simply never arrive. Take a second with that. Not because it should comfort you, it shouldn't. Because the more carefully you follow the logic, the more you realize this is not a promise. It is something stranger and considerably less reassuring than any version of immortality the human mind has ever invented. Here is what we are not doing tonight. We are not exploring near-death experiences or consciousness after death in any mystical sense, or the possibility that the soul persists in some dimension beyond the physical. Those are interesting conversations for other nights. What we are doing is following a thread that begins inside one of the most rigorously tested scientific frameworks in history, and ends in a place that makes experienced physicists uncomfortable enough to change the subject. The thread begins with quantum mechanics. It passes through the way reality branches every single instant of your life, and it arrives eventually at the question of what you actually are and whether the thing you call yourself is even the kind of thing that can survive. That last question is where the whole argument quietly falls apart. But we are not there yet. Let's start with what quantum mechanics actually says before anyone dressed it up in science fiction. The theory, developed through the first half of the 20th century by some of the most extraordinary minds in history, describes the behavior of matter and energy at the smallest scales with a precision that has never been matched by any other scientific framework. When physicists say quantum mechanics works, they are not being modest. They mean it predicts experimental outcomes to more than 10 decimal places of accuracy. It is not an approximation. It is not a rough model. It is, as far as anyone can tell, the most accurate description of physical reality that human beings have ever produced. And one of its unavoidable implications is that before you observe a particle, it does not have a definite state. It exists in a superposition of multiple possibilities simultaneously. The electron is not spinning up or spinning down until something interacts with it and forces a result. Before measurement, it is genuinely both, in a mathematically precise and physically real sense. This is not a limitation of our instruments. This is not ignorance about what is really happening underneath. Experiment after experiment has confirmed that the uncertainty is not about our knowledge of the particle. It is about the particle itself. Now here is where it gets personal. Very, very personal. Most of the time, quantum weirdness stays safely at the subatomic level, and you can go about your day without worrying about it. Atoms jiggle, electrons tunnel through barriers. Photons take every possible path simultaneously, and somehow, when all that activity adds up to the scale of a coffee cup or a human body or a planet, the weirdness averages out and you get classical behavior. Solid, predictable, ordinary. You don't phase through walls. Your morning coffee doesn't spontaneously rearrange itself into a different beverage. But what if the boundary between the quantum world and the classical world is not as clean as we have been assuming? What if the strangeness does not stop at some comfortable subatomic threshold, but continues, uninterrupted, all the way up to the scale of brains and bodies and the process we call consciousness? This is where the argument begins. And to understand it, you need to know about three things working together. The first is what quantum mechanics actually says about measurement, what physicists call the measurement problem. The second is a solution proposed in 1957 by a graduate student named Hugh Everett, who looked at the standard explanation and decided it was intellectually dishonest. And the third is a thought experiment proposed in 1998 by a physicist named Max Tegmark, who took Everett's idea seriously enough to follow it all the way to its most disturbing conclusion. Those three things together build the argument for quantum immortality, and that argument, as we'll see, contains a genuinely unsettling logical structure. It is not obviously wrong. It is not something you can dismiss in 10 seconds. When you follow it carefully, you arrive at a conclusion that seems to follow from the premises with uncomfortable necessity. But it rests on an assumption so quietly embedded in the reasoning that most people who hear the argument never notice it. An assumption about what you are. An assumption about what the thing you call I actually refers to. And that assumption, when you finally pull it out and look at it directly, turns out to be something that neither physics nor biology nor philosophy actually supports. By the end, the argument won't survive, but the thing that replaces it might be more unsettling than the original claim. Because the collapse of quantum immortality doesn't leave you with a simple, clean answer. It leaves you with a question about identity so fundamental that it threatens to dissolve the thing asking it. We will follow the logic all the way down, every step, no shortcuts. And by the time we arrive at the end, you will understand not just why the argument almost certainly fails, but why it feels so convincing in the first place, why it exploits something real about the structure of consciousness, and why the thing it exploits is not evidence that you will live forever, but evidence that the self was always a more fragile and temporary construction than any of us have been comfortable admitting. Let's begin. Part 2. Awareness has only ever experienced more. There is something strange about trying to imagine your own non-existence. Not the death of your body, which is easy enough to picture, at least abstractly. Not the stopping of your heart or the cooling of your skin. Those are physical events you can describe without too much difficulty, even if they make you uncomfortable. The strange part comes when you try to step into the after, when you try to imagine what it would actually be like, from the inside to not exist. To have no experience at all, to be nowhere, having nothing, perceiving nothing, and the strange thing is that you cannot do it. Not really. Every time you try, you're still there, watching the darkness. You're still the observer of your own absence. Consciousness keeps sneaking back into the picture because consciousness is the instrument you're using to picture anything at all. It is like trying to see the back of your own eye. The apparatus you're using to look is the thing you're trying to look at. This is not a trivial observation. It matters enormously to the argument we're building. Every moment you have ever experienced has been followed by another moment of experience. Every time you went to sleep, you woke up. Every time you were unconscious, awareness resumed. Your entire life from the inside is an unbroken chain of moments, each one leading to the next with no experience of the gaps between them. When you were under general anesthesia, you did not experience the hours of unconsciousness. You experienced going under, and then you experienced waking up. The middle was simply absent from your perspective, which means from your perspective it barely happened at all. You skipped it. You were on one side, and then the other. The Scottish philosopher David Hume pointed to something like this in the 18th century. He argued that when he looked inward, trying to find himself, he never caught himself in a state of pure existence. He only ever found particular things, a thought, a sensation, a memory, an emotion. He found bundles of experiences chained together, and he concluded that the self might not be a separate, unified thing standing behind all those experiences, but rather the experiences themselves, tied together by memory and habit and the impression of continuity. That impression of continuity is doing an enormous amount of work in this conversation. Think about what memory actually is. It is not a recording. It is not a neutral archive of events that happened to a stable person who is still standing here, unchanged, carrying all those events like luggage. Memory is reconstructive. Every time you remember something, you rebuild it slightly differently. The self you remember being at 7 years old and the self you are now are connected by a long chain of biological processes, gradual replacements of cells, shifting beliefs, accumulated experiences, and the narrative you tell yourself about what all of it means. There is no moment in that chain where a clear, discrete, permanent you was transferred from one body to another. You grew. You changed. You became someone who shares a great deal with that 7-year-old, but is not in any strict sense identical to them. The philosopher in you might be thinking, so what? We have a word for this kind of continuity. We call it personal identity. And it works well enough for everyday purposes, for signing contracts and remembering your own birthday, and feeling responsible for things your past self did. But the quantum immortality argument does not need personal identity for everyday purposes. It needs something much stronger. It needs a single, numerically continuous self that persists through branching quantum events, that has a definable location in a universe that is constantly splitting into multiple versions, and that has some principled reason to follow one specific thread of events rather than all the others simultaneously. And here is the crack in the foundation. The reason the quantum immortality argument feels intuitively convincing is not because physics supports it. It is because your awareness is structurally incapable of representing its own absence. Your brain cannot simulate the experience of having no experience, because the simulation requires experience to run. You cannot think your way to the inside of your own non-existence. And so, from the inside, continuation always feels like the only possibility. Not because it is, but because non-continuation is invisible to the apparatus doing the feeling. That cognitive limitation is about to become very important, because it is precisely this limitation that the quantum immortality argument exploits, whether intentionally or not. The argument takes a real feature of awareness, the fact that it has only ever experienced more awareness, and combines it with a real feature of physics, the fact that quantum mechanics allows for branching outcomes, and concludes that the two together guarantee something that neither of them, separately or together, actually guarantees. But before we can take that argument apart, we need to understand what the physics actually says. And to do that, we need to go back about 100 years and stand in the middle of one of the most uncomfortable, unresolved arguments in the history of science. Part 3. The crack in physics, the measurement problem. Something has been wrong with quantum mechanics since almost the moment physicists figured out it worked. Not wrong in the sense of being inaccurate. The equations are not inaccurate. The wave function, which describes the quantum state of a system, evolves with mathematical perfection according to the Schrödinger equation. You start with a wave function, you apply the equation, and you get an updated wave function. It is deterministic, continuous, and precise. There is nothing wrong with any of that. The problem arrives the moment you try to make a measurement. The wave function of a particle like an electron is not a description of where the electron is. It is a description of where the electron might be, spread across multiple possible positions, with each position weighted by a certain probability. The electron before measurement does not have a definite location. It has a range of possible locations encoded in the shape of the wave function. This is not an expression of our ignorance about the real location, as Einstein desperately wanted to believe. It is a statement about the particle itself. The location is genuinely indefinite until something forces the issue. Then you measure it, and something happens that the Schrödinger equation cannot account for. The spread of possibilities collapses to a single outcome. You find the electron here, not there, not somewhere in between, not in 3 places at once. Here, one result, a definite answer. The equation, which was doing so perfectly up until that moment, has nothing to say about this collapse. It does not predict it. It does not describe it. It simply ignores it. And yet experiments confirm it, again and again, billions of times a second in every quantum device ever built. The collapse is real, in the sense that you always get one answer, but the physics, as written, has no mechanism for it. This is the measurement problem. It has been sitting in the middle of quantum mechanics for nearly 100 years, and it has not been solved. There are responses to it. interpretations, frameworks, conceptual patches, but no consensus. None of the proposed solutions has been experimentally confirmed over the others. Every physicist who has ever tried to teach quantum mechanics has had to quietly sidestep the question of what measurement actually is, and what is actually happening when the wave function appears to choose one outcome. The most widely taught response is called the Copenhagen interpretation, associated with Niels Bohr and Werner Heisenberg. Its central instruction is essentially, when you observe the system, apply the collapse postulate, accept the one outcome you get, and do not ask what happened to the others. Shut up and calculate as the shorthand goes. The wave function is a tool for prediction, not a picture of reality. The question of what is really happening underneath the mathematics is not a physics question. It is a philosophy question, and physicists should leave it alone. This position is remarkably effective as practical advice. If you just want to build lasers and transistors and quantum computers, you do not need to worry about what the wave function really means. You need to know how to use it, and the Copenhagen interpretation tells you exactly how to use it. So for most working physicists, most of the time it is perfectly adequate. But it is deeply unsatisfying to anyone who wants to understand what is actually happening. The collapse postulate is not derived from anything. It is inserted by hand, after the fact, as a kind of rescue operation for a formalism that would otherwise predict that measurements always produce indefinite spread-out results instead of single answers. It works, in the narrow sense that it gives you the right predictions, but it does not explain, it patches. And different physicists looking at the same patch have proposed wildly different alternatives, hidden variable theories, consistent histories, frameworks, relational interpretations, and then, in 1957, something altogether more radical. Something that refused to patch the theory at all, and instead accepted what the equation was actually saying, all the way to its logical conclusion, no matter how uncomfortable that conclusion turned out to be. Someone, in other words, refused to let reality off the hook, and what he found waiting in the mathematics would eventually become the foundation of the quantum immortality argument. Part 4. Hugh Everett III refuses to collapse reality. In 1957, a graduate student at Princeton University named Hugh Everett III submitted a doctoral thesis that his advisor, John Wheeler, described as being in need of significant abbreviation before it was publishable. The abbreviated version was published. The full version, which was more explicit about its implications, circulated quietly for decades before physicists started to take it seriously. The core of Everett's argument was simple, and in retrospect somewhat obvious once you decided to take it seriously. He asked, what if the Schrödinger equation is always right? Not just sometimes, not just before measurement, always. What if there is no collapse? What if the wave function never contracts to a single outcome, but simply continues evolving exactly as the equation describes forever? If you take this seriously, you immediately run into the problem that the equation predicts indefinite spread-out results, and we always observe definite ones. Everett's solution was to say that the appearance of definiteness is what requires explanation, not the spread-out nature of the wave function. When you observe a particle, you, the observer, made of atoms governed by the same quantum mechanics as everything else, become entangled with the particle. You do not force the particle to choose. Instead, a version of you sees the particle here, and another version of you sees the particle there, and both of those versions continue to exist, each experiencing a perfectly definite outcome, neither aware of the other. Reality does not collapse to one outcome. It branches into all of them simultaneously. Physicist Bryce DeWitt, who championed this interpretation in the 1960s and 70s, gave it the name that stuck: the many worlds interpretation. The picture it paints is extraordinary in scope. Every quantum event that has multiple possible outcomes, every particle interaction, every radioactive decay, every photon that might or might not hit a detector, branches reality into multiple versions. Each version is equally real. Each continues to evolve according to the Schrödinger equation, and none of them can interact with or observe the others, because the branching process separates them as completely as if they existed in entirely different universes. How many branchings are we talking about? The number is incomprehensibly large. Physicists estimate that decoherence, the process by which quantum possibilities get separated into distinct classical-seeming branches, occurs at rates that make the number of branches per second per particle effectively incalculable. Every atom in your body is participating in this process, every moment of every second. The branching is not occasional and dramatic. It is constant, invisible, and total. And here is the emotional pivot that the quantum immortality argument is built on. In the many worlds framework, nothing is ever deleted. Every outcome that is physically possible gets a branch of its own. Every version of every event persists. When a radioactive atom decays, one branch of reality contains the decay and one contains the non-decay, and both continue forward. The universe does not choose. It keeps all of its options. Now ask yourself, if nothing is ever deleted, what does that mean for you? What does it mean for the particular arrangement of atoms and processes that constitutes your body and your awareness? If every outcome persists, and if you are part of the physical universe, then a version of you must persist in every branch where you continue to exist. And if there is always some branch, however improbable, in which you survive any given event, then somewhere in the structure of reality you are always still there. This is the seed of the argument. It feels, at first encounter, like it might be logically tight, and the reason it feels that way is that it is using real physics to draw its conclusion. The many worlds interpretation is not fringe speculation. It is taken seriously by a significant fraction of physicists working on the foundations of quantum mechanics. Sean Carroll at Caltech is an active proponent. David Deutsch at Oxford has argued that it is not just one interpretation among equals, but the most natural reading of the formalism. It is not the consensus view, but it is a legitimate scientific position, supported by real arguments and defended by serious people. So we have real physics, pointing to real branching, in a framework supported by real physicists. And the claim is that this branching, combined with the structure of first-person experience, means you can never run out of branches where you continue to exist. That claim is about to meet 4 very serious problems. But before we get to the problems, we need to build the argument in its strongest possible form, because you can only properly understand why something fails if you first understand exactly why it seemed like it might work. Part 5. The silent explosion of reality. The branching does not wait for dramatic events. This is something that gets lost in popular discussions of many worlds, which tend to focus on thought experiments involving cats and boxes and physicists making deliberate measurements. The reality is considerably more unsettling in its mundanity. Branching is not a special event that occurs under laboratory conditions. It is the continuous, relentless, microscopic process that underlies every moment of ordinary physical reality. The physicist Heinz-Dieter Zeh described in the 1970s how quantum systems interact with their environments in a process called decoherence. When a quantum system, say an atom in a superposition of 2 states, interacts with its environment, even a single air molecule brushing against it, information about the system's quantum state gets distributed across the environment. The 2 possible states of the atom become entangled with different states of the environment. And once that entanglement has happened, the 2 branches can no longer interfere with each other. They have become, for all practical purposes, separate worlds. The timescales involved make ordinary human intuitions useless. For a large molecule at room temperature, decoherence occurs in roughly 10 to the negative 23 seconds. That is a decimal point followed by 22 zeros and then a 1. There is no unit of experience remotely close to this. The branching is complete before you could even begin to perceive that there was anything to perceive. By the time any signal has travelled from your sensory organs to your brain, the branching has occurred a number of times that cannot be meaningfully written in ordinary notation. The branches do not interact. They never will. Whatever version of you is reading this in this particular branch is inaccessible to every other version of you that branched off from a common ancestor at some point in the last nanosecond. The separation is not physical distance. It is quantum orthogonality, a relationship between states that makes interference between them mathematically impossible under any circumstances short of reversing every single one of the countless interactions that created the separation. This matters for the quantum immortality argument in a specific and important way. The argument depends on a subjective observer tracking a continuous thread through the branching structure. But the branches are not a road with forks. They are a fog that becomes denser the closer you look. The idea of following a single thread assumes that there is a thread to follow, a well-defined continuous path through the structure of quantum reality that corresponds to a single observer experiencing a single history. But as we will soon see, that assumption is doing far more work than the argument lets on. Part 6. The scale of the split. The boundary between the quantum world and the classical world does not exist. This is one of the most important and underappreciated facts in all of physics, and it matters directly to whether quantum immortality could apply to beings like you and me. For a long time, popular accounts of quantum mechanics suggested that the strangeness, the superposition, the interference, the uncertainty, is confined to the very small. Electrons, photons, individual atoms, the stuff we cannot see. The implication was that once you get to the scale of visible things, molecules, cells, brains, people, the quantum weirdness is safely averaged away, and you can think in classical terms. That is not what the evidence shows. In 2019, researchers demonstrated quantum interference with molecules containing nearly 2,000 atoms. These are not exotic particles in a specially constructed laboratory. They are large, complex organic molecules, and they were made to interfere with themselves in a double-slit experiment, which is the canonical demonstration of quantum superposition. The interference pattern appeared exactly as quantum mechanics predicts, for objects vastly larger than anything we usually associate with quantum behavior. The implication is that the quantum to classical transition is not a matter of scale but of decoherence. Objects appear classical not because they stop being quantum, but because they interact so extensively with their environments that their quantum states lose coherence faster than any experiment can detect the interference. The underlying reality is quantum all the way up. What changes is not the physics, but the rate at which branching occurs. Your brain is part of this system. The neurons in your brain, the electrochemical signals they fire, the protein folding that governs receptor behavior, all of it is happening in a physical substrate that obeys quantum mechanics all the way down. The branching is occurring in your brain at every moment, at rates that dwarf any counting system you could construct. And if the brain branches, then the identity of the person whose brain it is must also branch, in some sense, along with it. This is the second piece of the foundation, and it creates a problem for quantum immortality that the argument has never adequately addressed. If identity branches with the brain, then the question is not whether you survive. The question is which of the versions that result from the branching is actually you, and that question, it turns out, has no clean answer. Part 7. The Bell Test Aftermath. There is one more piece of physical background that matters here, and it concerns whether strange interpretations of quantum mechanics are even necessary. Maybe quantum mechanics is strange at the mathematical level, but the underlying reality is completely ordinary, governed by definite, local, hidden variables that we just haven't found yet. Maybe the weirdness is in our description, not in the world. In 1964, physicist John Bell derived a mathematical inequality that could distinguish between ordinary local realistic physics and genuine quantum weirdness. If the universe operated on hidden variables in the way Einstein had hoped, Bell's inequality would be satisfied. If quantum mechanics was correct in its standard form, the inequality would be violated. Experimental tests began in the 1980s with Alain Aspect's landmark experiments in Paris. The violations were confirmed. Subsequent tests, each closing off potential loopholes, confirmed the violations again. In 2022, Aspect, John Clauser, and Anton Zeilinger received the Nobel Prize in Physics for their work on entangled photons and the violation of Bell inequalities. The result is definitive. Local hidden variables cannot account for the predictions of quantum mechanics. The universe is not built the way Einstein preferred. What this means is that any satisfactory interpretation of quantum mechanics has to involve something genuinely strange about the structure of reality. The options still on the table include non-local hidden variables, relational interpretations, and many worlds. But standard classical realism is ruled out. The strangeness is not in the description. It is in the thing being described. This does not validate quantum immortality. It validates the weirdness of quantum mechanics, which is a different claim. The fact that reality is strange enough to require a strange interpretation does not mean that any particular strange conclusion about death and identity follows from the strange interpretation. But it does mean that when we discuss many worlds as a legitimate framework, we are not being irresponsible with the physics. We are taking seriously an interpretation that belongs to a set of interpretations which are all, by necessity genuinely strange. The strangeness is real. The question is what it means for the people living inside it. Part 8. The asymmetry that changes everything. Here is the thing about the many worlds interpretation that makes it personally interesting rather than just abstractly interesting. It draws a distinction between two perspectives, and the distinction between those perspectives turns out to matter enormously. From the outside, from the third-person perspective of an observer watching events unfold, the many worlds interpretation is symmetric. All branches are equally real. When a radioactive atom might or might not decay, one branch has the decay and one branch does not. Both are there. Neither is more real than the other. An external observer who somehow had access to the entire branching structure would see all outcomes with equal ontological standing. From the inside, from the first-person perspective of a conscious observer inside the system, the situation is different. You do not experience all the branches. You experience exactly one branch. And the branch you experience is by definition the branch in which you exist to experience it. You cannot experience the branches in which you do not exist, because in those branches there is no you to do the experiencing. This creates an asymmetry, and the quantum immortality argument is built on this asymmetry. Think of it this way. Imagine you are standing in front of a quantum random number generator that has two possible outputs, 0 and 1. Each output happens with 50% probability. In the many worlds framework, when you press the button, reality branches. In one branch, the output is 0. In the other, the output is 1. Both branches continue to exist. Both branches contain a version of you who observed the output. Now change the scenario. Imagine the device is connected to a mechanism that will kill you if it outputs one. You press the button, reality branches. In the branch where the output is 0, you survive. In the branch where the output is 1, you do not. Both branches exist. But in the branch where you do not survive, there is no longer a you to have a first-person experience of anything. From the external perspective, you have a 50% chance of dying. From the first-person perspective, the only branch you can ever experience is the branch where you survived. The surviving branch is not more real or more likely than the fatal branch, but it is the only one that contains a version of you having an experience. Repeat this 1,000 times. In the many worlds framework, there is always a branch, however improbable, where the output was 0 every single time, and the version of you in that branch has observed 1,000 consecutive survivals. From the inside, it would feel like extraordinary luck, or perhaps like something more than luck. From the outside, it is just the inevitable consequence of the branching structure. Someone had to be in the lucky branch, and whoever is there experiences it as continuous survival. This is observer selection. It is structurally similar to the anthropic reasoning used in cosmology. The observation that we find ourselves in a universe capable of supporting conscious observers because we could not be in a universe that wasn't. Apply it to survival, and you get the core of the quantum immortality argument. The argument says, in any situation where some branches lead to your death, you can only ever experience the branches where you survived. Therefore, from your own first-person perspective, survival is guaranteed. Not because you are special, not because physics protects you, but because the branches where you don't survive simply don't contain a version of you to report on the experience. Max Tegmark is the physicist who formalized this most explicitly, and we are about to follow his argument with exactly the level of seriousness it deserves. Part 9. Max Tegmark and the Device. In 1998, Max Tegmark, a physicist who was then at the University of Pennsylvania, and later moved to MIT, published a paper that extended an earlier thought experiment by philosopher David Lewis into a full physical scenario. The thought experiment is called quantum suicide, and the idea is simple in structure and disturbing in implication. Imagine a device. It is connected to a quantum random event, specifically the spin of a single electron, which quantum mechanics guarantees will be measured as either up or down with equal probability. The device detects the measurement outcome. If the electron is measured as spin up, the device does nothing. If the electron is measured as spin down, the device immediately and painlessly kills the person connected to it. Now imagine you are the person connected to the device. You sit down. The device runs. The first measurement is made. In the many worlds framework reality branches. In one branch, the electron is spin up. The device does nothing, and you are alive. In the other branch, the electron is spin down. The device fires, and you are dead. From the external perspective of a physicist watching the experiment, there is a 50% chance that you die on the first run. The two branches are equally real. But from your perspective, the only branch you can experience is the one where you survive. The branch where you die contains no version of you available to experience dying. So from your first-person perspective, the device did not fire. The electron was spin up, you are still sitting in the chair, run it again. The same thing happens in the many worlds framework reality branches again. In some branches, the cumulative history includes a firing on the first run or the second. But you are not in any of those branches. You're in the branch where both measurements came out spin up. Run it 100 times, 1,000 times, 10,000 times. In the many worlds framework, the branching has created an enormous structure, an almost inconceivably large tree of outcomes. In the vast majority of branches, the device has fired at some point. In the overwhelming majority of versions of reality, a version of you died in this experiment. An external physicist watching this procedure would see you die very quickly, almost certainly within the first few runs, given the 50% probability per trial. But in one branch, one, out of the staggering multitude, the device has never fired. The electron has come up, spin up every single time, and in that branch, you are sitting in the chair, alive, having experienced nothing but continuation. From your first-person perspective, the device has simply never worked. You have survived 10,000 runs of an experiment that should have killed you almost immediately. The argument Tegmark makes is that this is not a special scenario. It is, in principle, what is happening to you right now, in the ordinary course of your life. You're not connected to a quantum death machine in a laboratory. But you are, every moment of every day, navigating a physical environment full of events that could, in some branches, lead to your death. A cell that might become cancerous, a car that might veer into your lane, a piece of food that might be contaminated, an aneurysm that might rupture. In the many worlds framework, each of these events is constantly branching. In many branches, some of these events have already gone badly. In many branches, a version of you died years ago. But in the branches where you continue to exist, you continue to experience continuation. And the argument says you can only ever be in those branches. This is not survival as you usually think about it. It is not luck in the sense that luck implies a single outcome that went your way. It is a structural feature of the relationship between branching reality and first-person experience. The argument claims you're not filtering for lucky outcomes. You are, by logical necessity, always in the outcomes where you're still here to do the experiencing. And here is what makes it genuinely unsettling rather than merely interesting. The argument does not require you to believe in anything supernatural. It does not require a soul. It does not require any mechanism for consciousness to travel between branches. All it requires is two things: the many worlds interpretation of quantum mechanics, and the observation that you can only have experiences in branches where you exist to have them. Both of those are defensible positions. The conclusion seems to follow with straightforward logic. This is the strongest version of the argument. Hold it carefully, because we need to understand exactly how it seems to work before we can understand exactly how it fails. Part 10. The realization. Let's slow down and sit inside this. If you are following the logic, you have just arrived at a place that should feel genuinely strange. Not strange in the way that dark matter or the expansion of the universe feels strange. Remote, abstract, about things very far away that have no immediate bearing on Tuesday morning. Strange in the way that a question about you, specifically right now, might actually have an unexpected answer. The reasoning runs like this. Quantum mechanics describes a reality that branches continuously, preserving all outcomes. In the vast majority of those branches, you die at various points. But the subset of branches in which you're still alive at any given moment is, by the logic of branching, non-empty. There will always be some branch, however improbable, where the cancer was caught early, the car missed, the storm didn't hit, the molecule folded correctly. And in all of those branches, a version of you continues to have experiences. From inside any one of those branches, the experience is continuous survival. Now here is the piece that makes this feel like more than abstract speculation. From your perspective, right now, reading this, you have only ever experienced continuous survival. Every moment of your life has been followed by another moment. You have never experienced your own death. You have never experienced non-existence. And the quantum immortality argument says this is not just a coincidence of your history so far. It is a logical necessity that will continue indefinitely. You will always be in a branch where you survived whatever just happened, because the branches where you didn't survive contain no version of you having experiences. There is no immediate logical contradiction in this. Let that register. The argument is not obviously wrong. It is not making a claim that can be dismissed with common sense. It is using the same physical framework that explains how lasers work, how MRI machines work, how semiconductors work, to argue for something that sounds like science fiction. And it goes further. The argument suggests that as you age, as the probability of survival in any given moment decreases, as the branches where you continue to live become progressively more improbable, the surviving version of you, the one having experiences, is threading through an increasingly narrow and unusual path through the branching structure of reality. The external world might see you die. Almost every version of reality contains a branch in which you died at what we would call a normal time. But there is always a branch, somewhere in the structure, where you did not, and that branch contains a version of you who is still there. This should feel uncomfortable, not inspiring, uncomfortable, because if you keep following the logic, you realize this is not a promise of a good long life. It is a promise of continuation in whatever form continuation is still physically possible. And physical possibility at the extremes of biology is not a pleasant standard to survive by. But before we get to why this version of immortality is nothing like the one you are hoping for, we need to ask whether the logic actually holds. We need to test the premises, and when we do that, we find that the argument has 4 serious problems. Problems that do not merely dent the conclusion but collapse the foundation it rests on. We are almost ready for the collapse. But first, we have to extend the argument one more step into the territory where it becomes viscerally strange, because only then will the failure be fully legible. Part 11. Scaling to real life. The thought experiment in the laboratory is one thing. Connecting it to ordinary human life is something else. Tegmark's quantum suicide setup is deliberately artificial. It isolates a quantum event, connects it to a lethal mechanism, and tests the argument under controlled conditions. But the real force of quantum immortality, if it holds, is not about artificially constructed devices. It is about the entire range of processes that govern whether you live or die at any moment. Consider disease. Cancer begins at the cellular level with quantum events. Radiation interacts with DNA. Molecules make copying errors. Proteins fold incorrectly. Immune cells either recognize and destroy aberrant cells, or they don't. Every one of these processes has a quantum substrate. Every one of them branches. In most branches, the cancer develops and progresses in the way that statistics describe. In some branches, the immune system catches it in a way that is statistically extremely unlikely. In vanishingly rare branches, the cancer simply never develops, or regresses spontaneously in ways that oncologists occasionally record and cannot explain. If quantum immortality holds, you're always in the branches where the cancer didn't win. Not because you were healthy or lucky in the ordinary sense, because the branches where it did win don't contain a version of you to experience the winning. Consider accidents. A car travelling toward you involves countless quantum events in the physics of combustion, in the driver's neural firing patterns, in the road surface, in every variable that determines whether the collision occurs. In most branches, if conditions are dangerous enough, the accident happens. In some branches, they don't. The quantum immortality argument places your subjective experience always in the branches where they didn't. Not because you were fortunate, because the other branches are simply not available to your subjective experience. Consider aging itself. The gradual accumulation of cellular damage, the shortening of telomeres, the declining efficiency of repair mechanisms, all of this is happening at the quantum level. All of it is branching. Most branches lead to the biological processes that we call aging and eventual death. Some branches, improbably, do not. Some branches contain versions of you where the degradation is slightly slower, slightly more repairable, slightly more manageable, and quantum immortality places you always in those branches. Now, here is where it becomes disturbing. The improbability of the surviving branches increases with time. When you are young and healthy, survival in the next moment is overwhelmingly probable even in classical terms. Most branches contain your continued survival. The quantum selection effect is barely distinguishable from ordinary statistics. But as you age, as the damage accumulates, as the probability of survival in any given moment decreases, the the surviving branches become increasingly exceptional, increasingly unusual, increasingly different from the normal distribution of physical possibility. What you would be surviving in, if the argument holds, is an increasingly improbable thread through the branching structure. The version of you that continues to have experiences is not the statistically typical version. It is the version in which every single cellular repair happened to go right, every single potentially fatal event happened to miss, every single process that normally leads to death happened to take an improbable turn away from it. At the extreme end of this, you are not surviving as a healthy person. You are surviving as whatever minimal form of continuation is physically possible, and the word living starts to fail as a description of what that continuation actually involves. This is the territory where the argument transforms from abstract philosophical speculation into something viscerally uncomfortable, because it is not promising you eternal life in any form you would recognize. It is promising that something continues, a biological minimum, a flicker. And the question of whether that flicker is still you, whether it still has a first-person experience in any meaningful sense, is the question that finally breaks the argument apart. Part 12. The hidden assumption. There is a thing inside the quantum immortality argument that nobody says out loud, and when you finally find it and hold it up to the light, the entire structure loses its footing. The argument assumes a single, continuous, numerically identical you that persists through the branching, not just a version of you, not just someone who shares your memories and your physical structure and your subjective sense of being you. A specifically singular you, a thing with a definite address in the branching structure of quantum reality that can be traced from one moment to the next through the enormous complexity of a universe that is splitting in countless ways every nanosecond. Where exactly is this you? What physical object is it? What property of your brain or body constitutes the unique identifier that quantum immortality is supposed to protect? The philosopher Derek Parfit spent decades working on this question, and his answer, laid out in his 1984 book Reasons and Persons, was both clear and devastating. Personal identity, Parfit argued, is not what we think it is. When you ask whether you're the same person as the person you were 20 years ago, you're not asking about a deep metaphysical fact about some persisting soul or continuous substance. You're asking about a set of psychological connections, memories, personality traits, intentions, relationships, the narrative you carry about your own life, that link one person's stage to another. These connections matter, Parfit argued. They are not nothing, but they do not constitute numerical identity. They constitute a kind of continuity that admits of degrees, and this matters enormously when branching is involved. Consider what actually happens to identity in the many worlds framework. When reality branches, both branches contain a person who is, in every measurable psychological sense, continuous with the person who existed before the branch. Both have the same memories. Both have the same personality. Both wake up the next morning remembering yesterday, convinced they are the same person they were the day before. Both have an equally valid claim to being the continuation of the pre-branching person. So which one is you? The question has no answer within the physics. The physics does not mark one branch with a special authentic continuation flag. Both branches are equally valid continuations of the pre-branching state. The physical facts run out precisely at the point where the identity question becomes pressing. You might try to answer this by saying, I am the branch that is in my perspective right now. That's me, by definition. The other branches are other people. This is a reasonable thing to say, but it immediately creates a problem for quantum immortality. Because if both branches have an equally valid claim to being you, then saying you will always be in the surviving branch requires you to explain why the other branch, the one that doesn't survive, doesn't count as you dying. The physics doesn't give you a reason. The other branch is just as you as this one is. Parfit's own conclusion was radical and to many people disorienting. He argued that what really matters about the future is not whether the person in the future is you, in some strict numerical sense. What matters is whether the person in the future is psychologically continuous with you, whether they share your memories, your values, your relationships, your sense of who they are. And branching, he thought, was simply a case of fission. One person becomes two. Both are continuous with the original. Neither is numerically identical to the original in any meaningful metaphysical sense. If Parfit is right, and his argument is extremely difficult to refute, then quantum immortality is protecting the wrong thing. It is claiming to preserve a singular you that was never, in any physically grounded sense, singular. It is arguing that a specific thread through the branching will always contain you, when the physics and the philosophy both suggest that the branching creates many threads, each of which is equally you in every sense that could matter. The argument is not keeping you alive. It is keeping some versions alive and calling one of them you by default. That is a very different claim. Part 13. Problem 1. Probability breaks. The first formal problem with quantum immortality is about probability, and it is serious enough on its own to do significant damage to the argument before we even get to the identity issues. Here is the problem. The many worlds interpretation, taken as a complete physical theory, needs to account for the fact that quantum probabilities have definite values. When you flip a quantum coin, the probability is not just any number. It is precisely given by the Born rule, which says that the probability of an outcome is proportional to the squared magnitude of the corresponding term in the wave function. And the Born rule is one of the most experimentally confirmed features of quantum mechanics. It works. Every experiment confirms it, to extraordinary precision. But if all branches are equally real, why do some outcomes seem to happen more often than others? In the many worlds framework, every outcome happens somewhere, in some branch. So in what sense is it meaningful to say that one outcome has a higher probability than another? Physicists David Wallace and Sean Carroll, both proponents of many worlds, have spent considerable effort trying to derive the Born rule from the structure of the many worlds formalism. The approach, associated with work by David Deutsch on decision theory, argues that a rational agent in a many worlds universe would behave exactly as if the Born rule probabilities were objective frequencies. This is clever and mathematically sophisticated, and there is genuine debate about whether it works. But here is the implication for quantum immortality. If the Born rule is in any sense valid in the many worlds framework, if the probability structure of quantum mechanics reflects something real about the branching, then survival branches that require improbable chains of events have a lower decision theoretic weight. They are in some sense less likely to be the branches in which a rational agent would expect to find themselves. You should not act as if you will survive 10,000 runs of the quantum death machine, because the branch where you survive all 10,000 has an extraordinarily small probability amplitude, and a rational decision maker takes probability amplitude seriously. The quantum immortality argument essentially claims that probability becomes irrelevant when survival is at stake. It says that the only branches that matter from your first-person perspective are the branches where you survive, regardless of how improbable they are. But this amounts to saying that your subjective experience is immune to the probability structure of quantum mechanics, that the measure assigned to branches by the Born rule has no relevance to which branch you find yourself in. That is an extraordinary claim, and it requires a mechanism. How exactly does your subjective experience navigate to the surviving branch? What physical process ensures that the thing you call your awareness ends up in the improbable branch rather than the probable one? The argument has no answer. It simply assumes that first-person experience must always land in a surviving branch, because the non-surviving ones don't contain the first-person experience. But this ignores probability completely. It treats all surviving branches as equally accessible, regardless of their amplitude, which is not what quantum mechanics predicts. In ordinary probabilistic terms, if you play Russian roulette, you should not expect to survive, even if you believe in many worlds. The branch where the gun doesn't fire has a very low amplitude. The branches where it does fire contain most of the probability measure. And while yes, there is a branch where you survive, the Born rule tells you not to count on being in it. The argument survives only if you accept a very specific and completely unjustified additional premise, that first-person experience tracks the rare high survival branches, regardless of their probability weight. And there is no physical, philosophical, or mathematical reason to accept this premise. Part 14. Problem 2. The self was never stable. The second problem goes deeper, all the way to the foundation of what the argument is claiming to protect. We established in the previous section that branching creates multiple successors, each of whom has an equally valid claim to be the continuation of the pre-branching person. Now let's follow that through its full implications for identity and continuity. The branching is not occasional. It is constant. Every moment of every second, the physical substrate of your brain is participating in quantum events that branch. Your neural firing patterns are governed by processes that involve quantum mechanics at the level of ion channels, neurotransmitter binding, protein dynamics. The precise timing and pattern of your thoughts, right now, is influenced by quantum-level events that are themselves branching continuously. This means that the person you were 1 second ago has already branched into an enormous number of successors, each of whom has a slightly different version of the thoughts that were forming. Some of those versions of you thought of that word you were reaching for, some didn't. Some of them had a slightly different feeling about the thing you were reading. The differences are tiny and mostly imperceptible, but they are real, and they are ramifying. With every passing second, the tree of versions grows. Now the question is, which version is you? You will say, the one having this experience right now. And that is a reasonable answer, but notice what you are doing. You are identifying yourself with a particular branch not because you have some special metaphysical connection to it, but because you happen to be in it. Any other version of you in any other branch is making the same claim. They are all equally in their branch. They all experience themselves as the continuous, real, authentic you. They all have the same memories, the same sense of identity, the same conviction that they are the one. The philosopher's term for this is the fission problem. When one person divides into two, there is no principled way to say that one of the resulting people is the original and one is the copy. Both have the same claim. And when the fission is continuous and constant, as in the many worlds framework, the concept of numerical personal identity becomes genuinely unstable. There is a famous thought experiment in philosophy of mind called the teletransportation paradox. Imagine a machine that scans your body and brain state completely, transmits the information, and reconstructs an exact physical copy of you at the destination. The original is destroyed in the process. Is the person at the destination you? Many people have a strong intuition that it is. They have all your memories, your personality, your continuous psychological narrative. They wake up in the morning convinced they are you. Now imagine the machine malfunctions and does not destroy the original. Suddenly there are two of you, both equally you in every psychological sense, both equally convinced they are the original. Which one is really you? The question cannot be answered, because the concept of numerical identity has come apart. There is no unique fact to discover. There are just two people, each with an equally valid claim to a shared history. This is the situation you are in, continuously, in the many worlds universe. Every quantum event that branches the physical substrate of your brain creates a fission event. The number of people who have an equally valid claim to being you has been growing at an incomprehensible rate since the moment of your birth. The quantum immortality argument claims to protect you, specifically, singularly you, through all of this. But the physics has no way to designate a specific one of these branches as the authentic continuation. The argument is claiming to protect something that, in any physically meaningful sense, has never existed. The self as a stable, singular, persistent object is a construction. It is a useful construction. It is the thing that allows you to sign contracts and feel responsible for your past and plan for your future. But it is not a fundamental physical fact. It is a pattern, a process, a narrative imposed on a substrate that is continuously branching and diverging, and a pattern cannot be immortal in the way that quantum immortality requires. You cannot guarantee the survival of a pattern by pointing to the branches where it continues, because the pattern is not the same in every surviving branch, and there is no physical mechanism that privileges the most continuous versions over the rest. The argument is protecting something that, in the most rigorous physical sense, was never the kind of thing that could be protected. Part 15. Problem 3. Biology does not cooperate. The third problem is less philosophical and more viscerally physical, and in some ways it is the most immediately devastating. Death is not a switch. It is not a binary event in which one moment you are a conscious person with a continuous subjective experience, and the next moment the experience is simply terminated. Death is a gradual dissolution. The brain does not stop all at once. Different regions lose function at different times. The process of cellular death spreads unevenly. Consciousness, which is not a separate thing but a process implemented by the biology, degrades as the biology degrades. What this means for quantum immortality is that the question is there a branch where this person survives, is not always answerable by a clean yes or no. In many of the scenarios the argument depends on, the surviving branches are not branches in which you are alive and conscious, and having continuous experiences. They are branches in which some subset of the processes that constitute your biological functioning continue for a while longer. Some neurons fire, some cells metabolize, some signaling continues. Is that you? Is that a conscious experience? Is that the first-person perspective that the quantum immortality argument is claiming to preserve? The physicist Roger Penrose proposed in his books The Emperor's New Mind and Shadows of the Mind a speculative framework called orchestrated objective reduction, often abbreviated ORC-ORA, which attempts to connect consciousness to quantum processes in the microtubules of neurons. If something like ORC-ORA were correct, consciousness might have a specific quantum substrate, and questions about the continuity of consciousness might be answerable in quantum terms. But ORC-ORA faces a severe problem precisely from the physics that quantum immortality also relies on. Decoherence occurs in biological tissue at room temperature on timescales, many orders of magnitude shorter than the timescales of neural firing. The quantum coherence required for ORC-ORA to function is disrupted almost immediately by thermal noise. The brain is simply too warm and too wet for quantum coherence to persist long enough to do the computational work that ORC-ORA proposes. More importantly, even if ORC-ORA or something like it were correct, quantum immortality would need a specific physical mechanism, a way for the quantum states associated with consciousness to navigate through the branching structure and consistently land in the surviving branches. No such mechanism exists, even in speculative frameworks. There is no physics that provides a path for the self to jump between branches. There is no quantum lever that consciousness can pull to steer itself away from the fatal outcomes. Quantum mechanics describes what happens to physical systems. It does not describe what happens to the particular narrative you tell yourself about who you are. That narrative is implemented in the physical system, but it is not the kind of thing that shows up as a term in the wave function. It cannot be tracked through the branching. It cannot be preserved by a selection rule. The biological reality is that the processes constituting your consciousness can degrade gradually, and the branches in which something continues are not necessarily branches in which the something is recognizably you. The argument, taken to its logical conclusion in a biological context, does not promise that you continue. It promises that some physical process does somewhere, and the distance between those two things is the distance between genuine survival and something that deserves a different name entirely. Part 16, Problem 4, it cannot be tested. The fourth problem is, in some ways, the most philosophically decisive, and it concerns what kind of claim quantum immortality actually is. Science operates at its core on the principle of falsifiability. A claim is scientific if there is in principle some observation or experiment that could show it to be false. A claim that no observation could ever contradict is not a scientific claim. It may be a philosophical claim, a metaphysical claim, an interesting speculation, but it is not science. Quantum immortality is, from the outside, completely invisible. There is no way for an external observer to confirm that any particular person is in a quantum immortality scenario. From the outside, people die at the rates that statistics predict. Cancers kill, accidents kill, old age kills. There is no observable excess of improbable survivals that would distinguish a world where quantum immortality holds from a world where it doesn't. The entire effect is, by construction, confined to the subjective first-person experience of the person in question, but from the inside the argument is equally unfalsifiable. If you survive, the argument says, that's exactly what quantum immortality predicts. If you die, well, from your perspective you haven't experienced dying, so there's nothing to report. The claim is constructed in such a way that no experience you could have would contradict it. Survival confirms it. Death is invisible to the person who died, so it cannot disconfirm it. Tegmark himself has been careful to distinguish the thought experiment from a scientific claim. He has explicitly noted that quantum immortality is a philosophical implication of many worlds, not a scientific prediction. And he has noted that he would not personally take the risk of testing it. That is, he would not sit in front of a quantum death machine, because the probability argument suggests strongly that the surviving branches have very low amplitude, and a rational agent should not stake their life on landing in a low amplitude branch. This is an important concession. It means that even the physicist who formalized the argument does not think you should bet your life on it. If the argument was scientifically compelling, if the probability structure of quantum mechanics genuinely guaranteed that you would always find yourself in a surviving branch regardless of amplitude, there would be no reason not to test it. The fact that even its proponents wouldn't test it tells you something about how much confidence is actually warranted. There is a further philosophical issue. The argument relies on the many worlds interpretation being correct. But as we noted earlier, the many worlds interpretation is one of several interpretations of quantum mechanics, all of which are consistent with current experimental evidence. If the Copenhagen interpretation is correct, if there is genuine wave function collapse and only one outcome per measurement, then quantum immortality doesn't follow at all. The branching that the argument depends on simply doesn't happen. And since we have no experimental way to distinguish between interpretations, the argument rests on a premise that cannot currently be confirmed. The argument survives, in a sense, for the same reason unfalsifiable claims always survive, not because the evidence supports them, but because no evidence can refute them. That is not a virtue of the argument, it is a warning sign. Part 17. The curdled version of immortality. Let's set aside for a moment the four problems we've just examined. Let's grant everything. Let's say the many worlds interpretation is correct. Let's say identity is coherent enough to track through the branching. Let's say the probability issues can be resolved, and that biology doesn't create the obstacles we think it does. Let's give the argument every single thing it's asking for. Now ask the question nobody asks when they first encounter this idea. What would quantum immortality actually give you? Because here is the thing. Every time I've watched someone encounter this argument for the first time, there's a moment, you can see it happen, where the face does something. A kind of reluctant wonder, like they've just been told something they weren't supposed to know. And the emotion underneath that expression is unmistakably hope, not the loud kind. The quiet, slightly embarrassed kind that shows up when someone secretly wants something to be true. The assumption baked into that reaction, the emotionally loaded assumption that makes the argument feel like it matters, is that quantum immortality is good news, that it means something in the neighborhood of what religious traditions have always meant by eternal life, that you will continue, as yourself, recognizable, experiencing things indefinitely, that somewhere in the branching structure of reality, a version of you never runs out of mornings. But the argument doesn't promise that, not even close. When you follow it through carefully, when you stop at the point where the inspiring framing ends and the actual physics begins, what you find waiting there shares almost no features with any comforting vision of continued existence that any human tradition has ever offered. So let's follow it carefully. Let's actually look at what the surviving branches contain. When you're young and healthy, the picture is fine. The branches where you survive look mostly like your ordinary life, with small random variations scattered around the edges. You are recognizable as yourself. Your memories are intact. Your relationships are intact. The quantum selection effect, the mechanism by which your subjective experience always finds itself in a surviving branch, is barely distinguishable from the ordinary statistics of a healthy person moving through the world. Nothing strange is happening yet. The branches where you continue to exist are not particularly exotic. They are just your life, proceeding more or less normally, because the probability of your survival in any given moment is high enough that the surviving branches are common, unremarkable, and look exactly like what you would expect. Then decades pass. This is where the picture starts to change, and where the argument starts to reveal what it is actually offering underneath the word immortality. Biology accumulates damage. This is not a metaphor or a pessimistic framing. It is a physical fact about what happens to complex organic systems over time. Cellular repair mechanisms become less efficient. Telomeres shorten. Proteins misfold with increasing frequency. The immune system loses some of its precision. The cardiovascular system accumulates wear in ways that compound. The brain, which is doing the extraordinarily energy-intensive work of maintaining your consciousness and your memories, and your sense of who you are, is running on hardware that is gradually, measurably, irreversibly degrading. In the ordinary course of events, these processes lead to death, not all at once. Gradually, through a series of increasingly serious failures, the system that supports your experience winds down. This is what biology predicts. This is what statistics confirm. This is what happens in the overwhelming majority of branches to every complex biological organism. But in the surviving branches, the ones that quantum immortality claims your subjective experience must always occupy, something different is happening. The cancer that should have developed doesn't develop. The cardiac event that the accumulated arterial damage made nearly inevitable doesn't occur. The progressive neurological decline that typically accompanies the biology of extreme old age doesn't take hold in the way it normally would. And here I need to be precise because the word doesn't is doing something misleading in that sentence. The disease processes are not absent in the surviving branches. They are still happening. The cells are still accumulating damage. The proteins are still misfolding. The arterial walls are still showing the effects of decades of pressure and inflammation. All of that is occurring because the physics that governs these processes is still the physics that governs these processes. What is different in the surviving branches is not that the damage isn't happening. It is that the damage is, through increasingly extraordinary combinations of physical coincidence, failing to progress to lethality in the normal way. Not because of magic, not because some protective force is intervening, because in a branching universe with enough branches, there are always some in which the statistics broke in your favor one more time. One more improbable cellular repair, one more near miss at the molecular level, one more deviation from the expected progression. The surviving branches do not contain a healthy you. They contain a you that is surviving in the most minimal sense that the word can be stretched to cover. Some processes continuing, some cellular function persisting. The biological threshold of being alive in whatever technical definition of alive still applies at that point, not yet crossed. Now ask yourself what the person in that branch actually experiences, not the idealized, vigorous, clear-minded continuation that the word immortality conjures when you first hear it. Something much more ambiguous and much harder to look at directly. The things you associate with your identity, your clarity of thought, your capacity for conversation and connection, your ability to form new memories and maintain old ones, your sense of humor, your preferences, your relationships, your sense of being a continuous self moving through a recognizable life. These are not separate from the biology, they are implemented by the biology. They depend on the same hardware that is degrading. And as the hardware degrades, they degrade with it. A philosopher might call what remains a flicker. A neuroscientist might call it severely compromised consciousness, or might decline to call it consciousness at all in any robust sense. The rest of us, if we are being honest, would probably call it something we would not choose, if choosing were available. And that is the part the argument never mentions, that there is no choosing. Quantum immortality, if it holds, does not offer you the option to reach a point of sufficient degradation and simply stop. It does not offer you the peaceful end that most people, when they think carefully about how they would want to die, describe as their preference. It offers continuation, in whatever form continuation is still physically achievable, for as long as some improbable surviving branch exists to contain it. The exit that death normally provides is exactly what the argument is claiming to remove. This is not eternal life. This is something that wears the word survival as a costume while containing almost nothing of what makes survival worth anything. Not the preservation of a person, the preservation of a process. Not the continuation of a life with meaning and relationship and experience in any rich sense. The continuation of a biological thread, increasingly minimal, increasingly isolated, increasingly distant from anything recognizable, in branches so improbable that the broader structure of reality, every other version of the universe, every other branch of the vast quantum tree, has long since moved on to the world where you died at a normal time, in a way that made sense, leaving whatever you left behind. There is no gentle way to say what the argument is actually promising once you strip the inspiring framing off it and look at the physics underneath. It is promising you the worst possible version of existence. Not peaceful death, not the end of experience, not the clean termination that biology normally provides after a certain amount of time, a flicker, dimming across timescales that dwarf anything the human brain can genuinely hold, in branches so improbable, so far from the normal distribution of physical possibility that no other version of reality would recognize what is happening in them as living. That is what quantum immortality actually says, not what it sounds like, not what the name implies, not what the hopeful expression on someone's face when they first hear it is reaching for. What it actually says, when you take the word immortality off it and replace it with what the physics is genuinely describing, is something that should make you considerably more at peace with the alternative. Part 18, The Loneliness of Surviving Branches. There is another dimension of what quantum immortality would actually involve that almost nobody talks about, and in some ways it is the most emotionally significant problem with the entire argument. More significant than the probability issues, more significant than the identity fragmentation, more significant than the biological degradation we just walked through. It is this: even if the argument held in every other respect, even if you were always guaranteed to be in the surviving branches, the people you love are not. Let that sit for a second before we move on, because I think it is easy to read that sentence and nod and not fully feel what it is actually saying. The quantum immortality argument, if it works at all, works for conscious observers, any conscious observer. In principle, it applies to every person alive right now. Every person is, from their own first-person perspective, always navigating toward the branches where they continue to have experiences. Every person's subjective viewpoint is, by the logic of the argument, always filtering towards survival. So in some abstract sense, everyone gets the same guarantee. Everyone is always in their own surviving branches. But here is the thing the argument quietly glosses over. The guarantee is individual, it is not shared. It does not apply to pairs of people, or families, or friendships, or any of the relational structures that make a human life actually feel like a human life. The branching tree for your survival and the branching tree for the survival of someone you love are not the same tree. They overlap for a while when you're both young and healthy and the probability of survival in any given moment is high for both of you, but they are not identical. And as time goes on, as the branches required to keep either of you alive become increasingly improbable, the chances that those improbable branches are the same branches, that the particular combination of physical coincidences keeping you alive is also the combination keeping them alive, decreases steadily towards something very close to zero. Think about what this means in concrete terms. The improbable branch where you survive a serious car accident is not necessarily the branch where your passenger also survived. The physics that conspired, through some extraordinary sequence of molecular events, to keep your body functional through the impact is not obligated to do the same for the person sitting next to you. Their survival depends on their own branching structure, their own quantum history, their own thread through the tree. Yours depends on yours. The two threads run alongside each other for stretches, sometimes for long stretches, because shared environments create correlated outcomes, but they are not the same thread. And as the decades accumulate, as the branches required to keep you going become increasingly exotic and improbable, the correlation between your surviving branches and the surviving branches of anyone else in your life breaks down almost completely. The version of you that is still alive at 110, in whatever minimal biological sense that phrase applies, is in a branch of reality so far from the statistical mainstream that it has almost nothing in common with the normal distribution of outcomes. It is a branch defined by an extraordinary sequence of improbable physical coincidences, each one selected not because it was likely, but because it was the one that kept you going one more time. What are the odds that the people who matter most to you are also in that branch? Not because they are unimportant, not because the universe is indifferent to them in some personal sense, simply because their survival depends on their own sequence of improbable coincidences, and the intersection of two such sequences, the set of branches where both of you are still here, both still functional, both still recognizable as the people who knew each other, becomes vanishingly small as the improbability of individual survival increases. What this means, taking the argument fully at face value, is that quantum immortality is not just physically degrading. It is structurally, systematically, inevitably isolating. Every year that passes, more of the people who constitute the relational fabric of your life are in branches where they died. Not in some abstract statistical sense. Specifically, your parents, your oldest friends. The people who knew you before you became whoever you are now, who carry in their memories versions of you that you cannot access alone, who hold pieces of your history that exist nowhere else. One by one, in the normal progression of time, they move into branches that your surviving thread no longer intersects. And the you that continues to have experiences is a you that is left behind by each of those departures, accumulating absences the way the rest of us accumulate memories. This is not ordinary grief. Let me be precise about that, because the distinction matters. Ordinary grief is terrible and real, and one of the most significant experiences a human life contains. But ordinary grief has, built into it, the possibility of continuation. You lose someone and the loss is enormous, and time does its incomplete and imperfect work, and you build a life that incorporates the loss rather than being defined entirely by it. The relationships that remain take on new weight, new connections form. The social and relational landscape of your life changes, but it does not disappear. There is still a world to be in. What quantum immortality is describing is something structurally different. It is not grief followed by continuation. It is continuation defined by grief, in increasingly extreme form, with no mechanism for the social and relational regeneration that makes ordinary grief survivable. The surviving branches are increasingly exotic. The people who would form new connections with the version of you persisting in those branches would have to be in the same exotic branches. And the more improbable your branch becomes, the smaller the set of people sharing it with you. Albert Camus wrote, in one of the most famous opening lines in the history of philosophy, that there is but one truly serious philosophical problem, and that is suicide. He meant it in the context of what he called the absurd, the collision between the human desire for meaning and the universe's apparent indifference to that desire. The question he was asking was whether, given all of that, continuing to live is a rational choice. Quantum immortality, taken seriously, replaces that question with something that Camus never had to consider. Not whether it is rational to continue, but what the value of a continuation is when the continuation has been stripped of almost everything that gave the original life its meaning. Not whether to keep going, but what exactly is being kept going, and whether the word you still applies to it in any sense that should matter to the person who was you when the question was first asked. Because here is what the argument is actually preserving, when you follow it to its end. It is preserving your biological continuity, your physical thread, the minimum viable version of whatever process constitutes being alive in the most technical sense available. It is not preserving your relationships, because relationships require two people to be in the same branch, and the branches diverge. It is not preserving your community, because community requires shared context, and the context of your surviving branch has diverged so far from the statistical mainstream that the shared context is gone. It is not preserving your history in any living sense, because the people who carried that history with you, who remembered the same things, who could say, yes, that happened, I was there, those people are in other branches now. What is left is a thread, a biological continuity attached to the remnants of a person, something that has memories of relationships that no longer exist in any accessible branch, something that knows what it used to be, in the way that a photograph knows nothing about the people it depicts, but carries the record of them anyway. The philosopher might try very hard to argue that this thread still counts as you. They might cite the psychological continuity, the memories, the persistent narrative of self. And in a narrow technical sense, they might have a point. There is a chain of experience connecting the person in the improbable surviving branch to the person who started the journey. The chain is real, but identity, for human beings, has never been only about the chain. It has been about the web, the network of relationships and shared histories and mutual recognitions that locate a person in a social and relational space as much as in a physical one. Strip the web away, and what remains of the chain is something that carries the form of a person without the substance of one. The quantum immortality argument promises you the branches where you are still alive. It says nothing about whether those branches contain anything worth being alive for. And the answer, when you look carefully at what those branches actually contain, is that they contain less and less of what made being alive meaningful on a trajectory that does not reverse, toward an endpoint that the argument by design never allows you to reach. This is the loneliness at the heart of quantum immortality, not the poetic loneliness of the solitary explorer or the misunderstood genius, the structural, unavoidable, physically mandated loneliness of a thread that has outlasted every other thread it was ever woven with, surviving in branches so improbable that the rest of reality has moved on, in a version of the world that nobody else is in. Even if it works, it does not work the way it sounds. It does not preserve the life you have. It preserves something that was once that life, in a place that nothing else can reach, surrounded by the specific silence of everything that was supposed to be there and isn't. Part 19, the real trick. Now we can say what the argument is actually doing. And this part, I think, is the most important stretch of the whole conversation, because everything we have covered up to this point, the measurement problem, the branching, the probability issues, the identity fragmentation, the biological degradation, the loneliness, All of it has been attacking the argument from the outside, showing that the premises don't hold, that the logic has gaps, that the conclusion doesn't deliver what it promises. But there is one more thing to do, and it is different from all of that. It is not attacking the argument. It is explaining why the argument feels convincing in the first place. Because it does feel convincing, at least initially, and that feeling is not an accident. It is not a sign that you're being credulous or sloppy. It is a sign that the argument is exploiting something real. Quantum immortality feels convincing because it is built on top of a genuine and irreducible feature of consciousness, not a misconception, not cognitive bias in the ordinary sense of that phrase, a structural feature of first-person experience, something so deeply embedded in the architecture of awareness that you cannot think your way around it, because thinking is one of the things it underlies. The feature is this: you cannot experience non-existence. Say it out loud, and it sounds almost too obvious to be worth saying. Of course you cannot experience non-existence. Experience requires an experiencer. Non-existence means the experiencer is gone. The two things are mutually exclusive by definition. There is no inside of non-existence. There is no perspective from which the absence of perspective can be observed. The moment of your death, if it involves the genuine termination of your consciousness, is not available to you as an event you can be present for. It is not something that will happen to you in the way that a conversation or a meal or a piece of music happens to you. It is the end of the happening, and the end of the happening is not itself a happening. This is not a philosophical trick. It is a real feature of what consciousness is. Every moment of experience you have ever had has been, necessarily, an experience of still being here. You have never had an experience of not being here, because not being here is precisely what would prevent the having of experiences. Every morning you wake up, the very fact of waking is a confirmation, baked into the structure of the moment, that you survived the night. You did not receive a notification from outside informing you that you were still alive. The aliveness was the precondition for receiving anything at all. It was not the message, it was the medium. Every moment you are conscious is a moment in which your consciousness is, implicitly, confirming its own continuity. The awareness that you are still here is not information you gather from the world. It is woven into the fabric of having any experience whatsoever. You cannot be conscious and simultaneously be absent. Consciousness is presence, almost by definition. So every single data point in your entire subjective history is a data point that says, still here. Every experience, without exception, is an experience of continuation. Now here is where the argument makes its move. And this is the move you need to see clearly, because once you see it, the whole structure of quantum immortality becomes transparent. The argument takes this observation, which is real and genuinely interesting and philosophically worth taking seriously, and treats it as evidence about the future. It takes the fact that consciousness has only ever experienced continuation and concludes that consciousness will always experience continuation. It takes a true statement about the structure of experience and inflates it into a prediction about what reality will contain going forward. But these are not the same thing. They are not even close to the same thing. The fact that you have never experienced non-existence tells you something precise and limited. It tells you about the structure of experience. It tells you that the record of your subjective history has a very specific kind of bias built into it. A bias toward moments in which you were present to have the experience. That is all it tells you. It does not tell you that you will always be present. It does not tell you that presence is guaranteed by the physics of branching reality. It does not tell you anything about the probability of future events. It tells you that the record is incomplete in a specific and structurally unavoidable way. Here is the analogy that I keep coming back to because I think it is the clearest way to see what is happening. Imagine a journalist. They have worked in a city for 40 years. They have reported on everything: fires, elections, floods, accidents, economic collapses, moments of unexpected beauty and unexpected horror. They have an extraordinary archive, thousands of stories. And here is something interesting about that archive. They have never once reported their own death. In 40 years of comprehensive coverage, that one event is entirely absent from the record. Does this mean they will never die? Does the absence of that story from their archive constitute evidence that they are in some way protected from the fate that eventually comes for everyone? Of course not. It means that if they die, they will not be there to file the story. Their archive has a bias toward events they survived long enough to cover. That bias does not make them immortal. It makes their record incomplete in a very specific and entirely unremarkable way. The absence of the death story is not evidence of anything except the obvious fact that the dead do not write their own obituaries. Your consciousness is the journalist. Your subjective history is the archive. The absence of any experience of non-existence in that archive is not evidence that non-existence will not occur. It is evidence of exactly what you would expect given what experience is, a record compiled by something that has to be present to compile it, and therefore systematically missing the one event that ends the compiling. The quantum immortality argument takes this systematic absence and mistakes it for positive evidence. It looks at the archive and says, look, non-existence has never appeared in here, therefore non-existence cannot be in the future of this archive, but the absence is not positive evidence. It is a structural feature of how the archive works. It would be there regardless of whether non-existence is coming, because non-existence by its nature cannot show up in an archive of experiences. It is the thing that ends archives. You would see exactly this pattern, an unbroken record of continuation, with no experience of absence anywhere in it, whether you were going to live another 50 years or die in the next 5 minutes. The bias is real. The observation is real. The conclusion drawn from it is a non sequitur, and here is the precise nature of the error stated as clearly as I can state it. The first-person perspective cannot simulate its own absence. This is true, but the reason it cannot is not that absence is impossible. The reason it cannot is that simulation requires a perspective to run in, and absence means the perspective is gone. This is a constraint on what consciousness can represent. It is not a constraint on what reality can contain. Those are two completely different things, and conflating them is the single move that makes the quantum immortality argument seem to work when it doesn't. Consciousness can only find itself present. But that is a fact about consciousness, not a fact about the universe. The universe is not obligated to contain your consciousness simply because your consciousness cannot represent a universe without itself. The inability to imagine your own non-existence is a limitation of the imagination. It is not a force field. It is not a physical law. It is not a selection rule built into the branching structure of quantum reality. It is a cognitive constraint that has been quietly dressed up as a metaphysical guarantee, and the dressing is so seamless that most people who encounter the argument never notice it happening. This is why the argument is ultimately not physics. It feels like physics. It uses the language of physics. It references real experiments, real interpretations, real mathematical frameworks. But the core of it, the move that takes a structural feature of consciousness and converts it into a claim about physical reality, is psychology. It is a philosophical sleight of hand that writes the architecture of awareness into the fabric of the universe as if the two are the same document. They are not. Presence is what you find when you look, because looking requires presence. This is true and worth knowing, but when looking stops, the report of presence stops with it, and the stopping is real. The stopping is as real as anything the physics describes. It is simply the one thing that the thing doing the stopping cannot confirm, because confirmation is one of the things that stops. The argument survives in the end not because the physics supports it, not because the logic is tight, not because the identity assumptions are defensible, or the biological facts cooperate, or the probability structure works out. It survives because it is built on top of something you genuinely cannot see around. A blind spot that is not a flaw in your thinking but a feature of what thinking is. And knowing that the blind spot is there, knowing exactly what it is, why it exists, and why it cannot be argued away, is not the same as being free of it. You will still find, the next time you try to imagine your own non-existence, that the imagination fails, that you keep showing up in the picture, that the darkness you're trying to inhabit has you standing in it, watching. That is not evidence of immortality. That is what it feels like to be a conscious thing trying to think about the end of consciousness. The limit is real. The conclusion people draw from it is not. Part 20. Finitude as structure, not flaw. We have followed the argument all the way down, every step. We built it carefully, in its strongest form, giving it every advantage. We took the many worlds interpretation seriously. We took the observer selection logic seriously. We followed Max Tegmark's reasoning through the quantum suicide thought experiment without flinching. And then we tested the argument against 4 problems, probability, identity, biology, and testability, each of which is serious enough on its own to challenge the claim, and together constitute something more than a refutation. Together they constitute a systematic collapse, not a critique, a collapse. The foundation gives way, and the structure comes down with it. But here is the question I want to sit with for a while before we close. Not was the argument wrong. We have established that it almost certainly is. The question is what we are left with once it fails. What does the landscape look like after the argument collapses? Is what remains less disturbing than the argument? Or more? I think it is more disturbing. And I want to explain exactly why, because the reason is not obvious, and it matters. The argument, in order to work, required something specific. It required a stable, singular, persistent self, a specific you that could be tracked through the branching structure of quantum reality, identified across the tree of outcomes, and guaranteed to persist in the surviving branches. Not just a pattern that resembles you, not just a process that is continuous with you in some loose psychological sense. A you, the real one, the one that is reading this right now, that has been here for every moment of your life, that will either survive or not survive depending on which branches the physics selects. And what we found when we looked carefully at what physics and philosophy actually say about that self is that it does not exist. Not in any rigorous sense, not in any sense that the argument needs it to exist in. The self is a pattern, it is a process. It is a narrative constructed moment by moment from the continuous experience of being here, assembled by a brain that is itself branching, built from atoms that carry no record of whose atoms they are, that has been changing so continuously and so completely since the moment of your birth that the entity called you at age 7 and the entity called you right now share a history but do not share an identity in any strict metaphysical sense. The cells are mostly different, the beliefs are different, the fears are different, the things that feel important are different. The person who was frightened of the dark and the person who is now thinking about quantum mechanics are connected by a chain of experience and memory and biological continuity. But the chain is not the same thing as a fixed object persisting unchanged through time. Derek Parfit spent decades making this argument with extraordinary precision. What matters about the future, he said, is not whether the person in the future is you in some deep numerical sense. What matters is whether they are psychologically continuous with you, whether they remember what you remember, value what you value, carry forward the projects and relationships and commitments that constitute your life. And his radical conclusion was that this kind of continuity is what we should care about, because the deeper question is that really me, in the strict sense, does not have a determinate answer. The physics runs out before the question is resolved. Buddhist philosophical traditions arrived at something structurally similar from a completely different direction, over the course of thousands of years of careful introspective inquiry. The self, examined closely enough, dissolves into a stream of arising and passing moments, none of which contains a fixed, permanent thing that is the self. What we call the self is a construction, a useful one, a real one in the sense that it has effects in the world and matters to the people around you, and structures your experience in ways that are not arbitrary, but not a substance, not an object, not the kind of thing that quantum immortality needs it to be. Now here is where this gets important in a way that goes beyond the failure of the argument. If the self is a pattern rather than an object, then death is not what we instinctively feel it is. We feel it as the destruction of something, the loss of a specific, irreplaceable thing that was located somewhere, that had a particular history, that mattered in ways that nothing else does. And that feeling is real and the loss is real. But the metaphysics underlying the feeling may not be what we assume. If the self is a process, then death is the cessation of a process. And the cessation of a process is a different kind of loss than the destruction of an object. The pattern never had a fixed location to be lost from. It was always distributed across time and biology and relationship and memory, never residing fully in any single moment or any single piece of matter. This does not make death unimportant. Please do not hear it that way. The cessation of a process that you loved, or that loved you, is still enormous. The ending of a pattern that was irreplaceable in the specific texture of what it was is still a real loss. Grief is appropriate. The weight of mortality is appropriate. I'm not trying to philosophize the significance of death away, and I do not think the physics does that either. What I am saying is that finitude understood clearly is not a flaw in the design, it is the design. And the failure of quantum immortality is what makes that visible in a way that is hard to dismiss as mere consolation. Think about what it would actually mean for your life to have no end. Not the romantic version of immortality, where you remain vigorous and curious and connected indefinitely. We already walked through what the physics actually implies about that version, and it is nothing like the romantic picture. But set even that aside. Think about what infinite time would do to the structure of meaning in your life. The meaning you find in your relationships depends structurally on the possibility of losing them. The weight that a conversation carries, the sense that this exchange matters, that what is said here is worth saying, that the connection being made right now is real and significant, depends on the fact that the conversation will end, that the person you're having it with is finite, that neither of you will always be here. Remove that possibility, and you do not get a more meaningful conversation. You get something that is harder to take seriously, something that can always be continued later, revised, returned to, because there is always more time. And when there is always more time, the urgency that makes this time matter quietly drains away. The weight you attach to your choices, the sense that deciding one way rather than another actually has consequences that you will carry, depends on the irreversibility that finitude provides. You make a choice, and the version of your life in which you made the other choice recedes, not into another branch of quantum reality that you can somehow reach, into the past which is fixed and unreachable. The finitude of your time is what makes the choice real, what makes it a choice rather than a preference you can always revisit. Risk is only risk if loss is real. Love is only love if the loved thing can be lost. The shape of a life is defined by its edges. The fact that it begins somewhere and ends somewhere is not an unfortunate limitation on an otherwise good thing. It is the condition for the thing being the kind of thing it is. A life without edges is not a longer life. It is a different kind of thing entirely, something that lacks the properties that make a life legible as a life. Every serious philosophical and religious tradition that has grappled with mortality has circled around some version of this. The Stoics built an entire practice around the contemplation of death. Memento mori, remember you will die. Not as a morbid exercise, but as a tool for recognizing the value of what is present. The Buddhist concept of impermanence is not a counsel of despair, but an invitation to be fully in contact with the actual texture of experience, which is always in motion, always changing, always arriving and departing. The existentialists from Heidegger forward argued that authentic existence requires confronting finitude rather than evading it, that the awareness of being toward death is not a burden added to life, but a structure that makes genuine choice possible. What quantum immortality in its failure clarifies is why these traditions are not just offering poetic comfort. They are pointing at something structurally necessary. The clock does not diminish the experience. The clock is the condition for the experience having the weight it has. Remove it, and you do not get more of what the clock was measuring. You get something that was never the point in the first place. There is one more dimension to this that I want to name before we close, because I think it is the most personally significant piece of everything we have covered tonight. The self that quantum immortality is trying to preserve is the self as a fixed thing, a stable identity that persists unchanged through the branching. But the experience of being a person, the actual lived texture of what it is like to be you, moving through time, is not the experience of being fixed. It is the experience of changing, of learning something that reorganizes how you understand everything else, of being in a relationship that gradually, without your fully noticing, makes you into someone different from who you were before it, of encountering loss and discovering that the person who comes through the loss is not identical to the person who entered it. The you that would survive in quantum immortality's increasingly improbable branches is not the version of you that grew. It is the version of you that persisted. And persistence, in the absence of the processes that make growth possible, in the absence of genuine risk, genuine relationship, genuine change, is not a continuation of your life. It is a shadow of it, a record of something that is no longer happening. What makes a life valuable, when you press the question seriously, is not length. It is not extension in time. It is not the persistence of the pattern in as many branches of quantum reality as possible. It is something about the quality of the experience, the depth of the connections, the significance of the choices, the texture of the ordinary moments, The way that love and loss and learning accumulate into something that has the specific, irreplaceable shape of a particular life and no other. And all of those things, every single one of them, depend on the life being finite, depend on it being the kind of thing that can end. We started this conversation with a sentence that was meant to be unsettling. You may never experience your own death. And in a narrow sense, that may be true. Not because quantum mechanics guarantees your survival in some branch of a branching universe, but because the experience of death, from the inside, is not available as an experience. There is no inside of it. The perspective closes, and there is no report from the closed side. But here is what that realization actually means. Once you strip away the false comfort the quantum immortality argument was trying to wrap around it, it means that the time you're experiencing right now, this moment, this particular arrangement of thoughts and sensations and half-formed reactions, is the time that exists for you. Not because nothing comes after, but because the future is not available to you yet, and the past is not available to you anymore, and the only address the pattern called you has ever actually occupied is the continuous present of its own experience. The universe is branching. You are branching with it. Somewhere in the structure of quantum reality, versions of you are having slightly different thoughts right now, because the quantum events underlying your neural firing patterns branched a fraction of a second ago. They are all real. They are all equally you, in every sense that physics can measure. And they are all, each one of them, navigating the same irreducible fact from slightly different angles. That fact is not that you live forever, it is that you live now. And now, however it is structured by physics, however it is divided by branching and decoherence and the unresolved measurement problem, is the only place the pattern has ever actually been. The question that quantum mechanics ultimately raises about death is not whether you survive. It is whether the thing you are trying to preserve was ever the kind of thing you thought it was. Whether the you that wants to continue is the kind of object that can continue, or whether it is something more like a flame, real, warm, capable of illuminating things, but not the kind of thing that gets preserved. The kind of thing that burns. The most terrifying thing quantum mechanics reveals about death is not that you might be immortal in some impoverished, degraded, isolated sense. It is that the thing asking the question, the self that wants to know whether it survives, that has been with you through every word of this conversation, that will close this window or set down this phone and go back to the rest of its life, was always more fragile, more constructed, more temporary than it knew, not as a reason for despair, as an invitation to look at what is actually here in the time that is actually available, with something closer to the attention it deserves. Understanding that is not the end of the question about how to live. It is, if anything, where the question actually begins. Some nights the most honest thing physics can give you is not an answer. It is a better question. And the question this particular corner of physics leaves you with after all of this is not, will I survive? It is something quieter and harder and considerably more worth asking. What exactly is it that I am trying to preserve? And is the preserving, or the living, the thing that matters? The equations do not answer that. The branching structure of quantum reality does not answer that. The measurement problem, unresolved after 100 years, does not answer that. That part, after everything, is left entirely to you.